Hi there kids, today we're going to talk about some of the other branches that we can put on alkenes and alkanes and alkynes. We're going to talk about a special ring that pops up a lot. Remember, a cyclic structure that pops up a lot in chemistry. And let's dive right on in. First thing we should do is review. Try these two examples, draw structures for them, try it out in your notes. Pause the video while you give that a shot. If you're ready to look at some solutions, we can look at some solutions together. Let's get a pen here. The first important part of this is the hexene, the main branch. So I've got 6 carbons. 6 and hex both have an X in them. And it ends in ene, so it tells me there's a double bond. And it's going to come after carbon number 1. That's what the 1 in front of the word hexene means. Everywhere else there will be single bonds. And then 3,3 tells me I have 2 branches on carbon number 3, dimethyl, and a methyl branch only has 1 carbon. So then my goal is just to slap in extra hydrogens wherever they may be. Every carbon needs to have 4 bonds. So I'm going to add hydrogens until everything has 4 bonds. And if you wrote things like this one as CH2, that's just fine. So this is 3,3-dimethyl, 1-hexene. The next one, it's hex, so we're dealing with 6 again. It's ane and they're single bonds, but that cyclo is important. That cyclo tells me everything is in a geometric hexagon shape. Pretend those are straight lines. Shh. Alright. Now, I have to start somewhere in numbering in this ring. I might as well pick right here just because it's handy. And I'm going to put my chlorine there. That's the 1-chloro. And then I can choose clockwise or counterclockwise. At this stage it doesn't really matter to get to my second branch. I'm going to go this way, number 2. Pardon me there. Number 2 there. And that is ethyl, which is CH2, CH3. So now I have 1-chloro, 2-ethyl, cyclohexane. But those are review. Let's look at some new things today. Let's look at this as an example. We may want to try to name this compound by looking for that longest string of carbons. 1, 2, 3, 4, 5, 6, 7 carbons in a row. And that would give us a heptane structure. But let's look at this branch off of carbon number 4. There are 3 carbons in it. So I want to call it a propyl group. But you'll notice something different about this. Our branch is connected from its middle carbon, not from the carbon on the end, the way we've been doing. We need to have some way of indicating where on the branch this carbon is attached. This situation, where the carbon is attached to a center of a branch, gets us a prefix to use. It's iso. You've probably heard this before with isopropyl alcohol. So this branch will be 4-isopropyl. The 4 tells me where on the main chain it's connected. The iso tells me that my propyl branch is connected from its center carbon. And then heptane for the main chain. Let's try this one. 4-isopentyl decane. Go ahead and pause the video here. You give it a shot, and then we'll look at the solution together when you're ready. Alright, let's check out how it goes. So decane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's ane, so they're all single bonds. Off of carbon number 4, I have a pentyl branch, and pent means 5. But the iso tells me I'm stuck to the middle of that 5-carbon branch. So 1, 2, 3, 4, 5. Pentyl for 5, iso to show the branch is stuck to the center one. And then we can fill in the hydrogens as needed, so that every carbon has 4 bonds. There's no funny numbering to have to learn. Just remember, if you see that iso in front of a branch name, that the branch will be stuck to a center carbon. It'll always be put onto something that has an odd number, so it'll be propyl, or pentyl, or heptyl, or nonyl, though we really won't see that very often. We'll teach you how to deal with some of the other odd branches later on. It's good enough for now. Now I want to teach you about a special ring today. This ring is called benzene. There's a cool little podcast about where benzene got its structure that's on our website. The benzene ring is found a lot in nature. It's found a lot in chemicals that we produce as well. In benzene, I have a cyclohexene compound. It's actually a triene because I've got 3 double bonds. But you'll notice I've got 2 ways of writing it. If I number my carbons 1, 2, 3, 4, 5, and 6, sometimes I've got a double bond between 1 and 2. If I have the same carbons here, sometimes I have a single bond between 1 and 2. The truth is, there's a constant flip-flop as each bond trades places. We call this a resonance structure, 2 equally existing structures. This ring is so special it has its own special name, benzene. And a lot of times, to show that those double bonds are constantly in motion, we draw it like this. Well, let's show how we would use this in our structures. It's important because we find this in a lot of organic chemicals. And they're unusually stable because those double bonds are shared evenly across all of the carbons. We find these a lot in large molecules that smell bad. As a result, we call that family of chemicals aromatics. Aromatics are organic compounds that have a benzene ring in them. Now, if that benzene ring happens to be a branch on something bigger, like an octane, then we're going to give it another name. If I use benzene as a branch stuck to something, I'm going to call it phenyl. Here's an example. I've got heptane, and stuck onto carbon number 3 is the benzene ring. The benzene ring only has 6 carbons. This chain has 7. So 7 carbons is our longest string, so it's really important. I'm going to go ahead and label this as a phenyl branch. So that would make this 3-phenyl heptane. It's a lot easier to use that phenyl as a branch name than to try to have a branch name that includes 7 carbons where the branch is attached to carbon number 3. So 3-phenyl, phenyl is our benzene, stuck as a branch. 3 tells me which carbon it's stuck on in the chain of heptane. I guess I wrote it there so I didn't have to write it out. Well, too bad for you, you got both. Try these out. You can pause it while you give it a shot and then tell the instructor when you're ready to go. We'll advance forward. 1-bromo, 3-methylbenzene. So benzene's the important part, so I'm going to draw a benzene ring like this. I'll pick one of the carbons to be number 1, and we'll call that bromo. 2, 3, so this is my 3rd carbon, and it's methyl, so I'll put CH3. Ta-da! It's not too bad. Let's try the next one. 1-chloro, 5-isopropyl benzene. So once again, draw my benzene structure to start with. It's a hexagon. Oh my goodness, that's terrible. That's why we can't have nice things, kids. Let's see if I can draw that better. Eraser. Here we go. Pointer options. Boom. Alright. Start to see why something like ChemSketch is so valuable. So benzene, 1-chloro, 2, 3, 4, 5. Now off of carbon number 5, I'll have a branch, and it's isopropyl. The prop tells me there's 3 carbons. The iso tells me the branch is off of the center carbon. So that makes this H3, There's an H stuck to this guy. This guy's H3 as well. And we have 1-chloro, 5-isopropyl benzene. Probably would have been better to name this 1,3, a number to give us the two branches closer together. And then on this last one, 1-phenyl cyclooctane. Alright, well let's see. Octane tells me I've got 8 carbons, single bonded. Cyclo tells me they're all in a loop. So for this one, I'm going to draw a stop sign. My octagon. Not the octagon. There's no cage fight going on here, kids. Alright, there we go. That's my beautiful octagon. You're probably really proud of your own octagon, I understand. But it will never measure up to mine. So there's cyclooctane. And stuck to one of them, I have a phenyl group, which is a benzene ring, which is a hexagon with those alternating double bonds. 1-phenyl cyclooctane. Isn't it beautiful? Hope you had fun with it. Now, give the assignment a shot.